standard deviation, I want to go back and discuss a couple of things that we've talked about in recent days, and those are shape, center, and spread. So we previously talked about some shapes. For example, we talked about a shape that kind of looked like this. We called that a skew right. We also talked about the shape that looked like this, which we called a skew left. And we said that when we had these distributions, that what happened was the median was closer to these peaks, closer to these modes. The median really represented the data well, while the mean was getting pulled towards the more extreme values. And so the mean didn't really represent the data. I think the one example that I gave you that was like, you're doing really well in a class, and then you get one bad grade and your mean, your average in the class goes down, when the median would probably be a better representation of your knowledge in the class because you had one bad grade compared to a lot of grades. And so if I was going to talk about the center of these distributions, I think that the median would probably describe these distributions much better than the mean would. We also talked about in recent days what happens off of the center. What are the other values in the distribution doing? And one way that we had to describe these other values was to use the 5-number summary and to talk about outliers. And we talked about how the 5-number summary helped us to put data into quartiles, 25% of the data, the top and bottom 25%, the middle 50%, the upper 50, the lower 50. And so it helped us to describe the spread of the data, not just the center, which was the median, but just how this data spread out from that center. We did also talk about a distribution that looked like this, and we called this a uniform distribution. And we mentioned that in a uniform distribution that the mean and the median were the same. And so really we could use either one if we wanted to describe it. I probably would still use the 5-number summary as a way to look at the spread of this data. And I'd see that there was approximately the same amount of data in the top 25% as the bottom 25%, as the middle 25% as well. We also talked about, and so this is the one that we're going to talk about today, and this is going to move us into Unit 4 and into Unit 5. So we're going to do a lot of discussions on the one that looked like this. And we talked about how this was unimodal. We talked about how it was symmetric, and we mentioned that it's a bell curve, and what we usually say is we say it's approximately normal. I don't know if it's exactly normal. Normal has a very specific definition to it that we'll talk about in the next unit, but it looks approximately normal to me. We also talked about how the middle of this, the mean and the median, were the same. However, when we describe the center, we usually stick with the mean on this one. And the reason that we stick with the mean is because when we're describing the spread, how far the data goes away, we use something that's called the standard deviation, or S, to describe it, and the standard deviation is based on the mean. So the normal distribution, the center we use is the mean. The spread we use is the standard deviation, which we're about to learn about right now. And if we have something else, a lot of times the median is more descriptive as the center, and we like to use the 5-number summary to talk about the percentiles and where the quartiles are and how wide or how narrow certain percentiles are. Okay, so let's go into an example. Here's my data set. I have 4 values in it, 7, 10, 12, and 15. And if I wanted to, what I like to do when I first get data is I like to graph the data. So if I just wanted to do a quick little graph, nothing too pretty, just to get an idea of what the data look like, maybe I'd go back to when I did a histogram and I'd create these intervals Maybe I do 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have the same amount of values in each one of these intervals. 7, 8, 9 has 3. 10, 11, 12 has 3. 13, 14, 15 has 3. There's one value from 7, 8, and 9. There are two values, 10, 11, 12, and there's one value, 13, 14, 15. So if I just do a sketch, this is obviously not my final copy. This is not something I would put down on a test. This is not something I would put down on a CA. But if I was graphing this, my first bar would go up to 1, my second bar would go up to 2, and my third bar would go up to 1. And I'd have, a great title to it, and there would be some labels down here. But me just getting an idea of what this looks like, it looks like I have a unimodal symmetric shape. And when I have a unimodal symmetric shape, I like to use the mean, and I like to use the standard deviation to describe the center and the spread. So I'm going to start with something that you know. And something that you know is the mean. This is the formula for mean. It may not look like any formula that you have seen before. I mean, you know the mean. Add everything together, divide by how many you have. That's what this formula says. The funny looking E is sigma notation. You probably saw it, that's a horrible arrow, isn't it? You probably saw it in Algebra 2A when we were talking about mathematical expectation. Maybe Evan did one of those vodcasts for you. But it basically means just to add stuff together. So if I was going to use this formula, I would do x bar equals, and then what I have is I have the sum of the x values, the sum of my values. My first value is 7 plus 10 plus 12 plus 15. So the sum of my values divided by n. And n is how many I have, which here n is 4. So divided by 4. So x bar equals, and I can add those all up, and I can divide by 4. 7 and 10, 17, 29, 44. So 44 divided by 4 equals 11. I know that from the data because my data is symmetric, so I know 11 is in the middle of that data. All right, so the center of this distribution is 11. Okay, so now I want to talk about the spread. How far are my values off of 11? I'm going to do a little bit of hand waving here. I'm going to give you a formula. You should be able to use the formula. You should be able to talk generally what standard deviation is about, but know that in Unit 4 and in Unit 5, we're going to talk way more about standard deviation. So we don't really have a formula for standard deviation. We have a formula for variance, and that's what we're going to find is the variance. But once we have the variance, it's easy to find the standard deviation because all we have to do is just take the square root of it. So the variance is the standard deviation squared, or the standard deviation is the square root of the variance. So we're going to find the variance here. So let me just remind myself really quickly that this data set that I have was 7, 10, 11, oops, not 11, it was 12, wasn't it? 7, 10, 12, and 15. And I have 4 values. So I'm going to find the variance. 1 over, and the first thing I run into is an n, which is my size, and that's 4 minus 1, which is 3. I'm about to do a summation, so I'm going to do some big brackets here. Okay, so I'm going to take my first x value, which is 7, minus the mean. I'm just following this formula, which was 11, I think, squared. So just following the formula. It's a summation, so I'm going to put a plus sign here. And then I'm going to do my next x value, which is 10, minus the mean, squared, plus. I wish I could go off to the right, but I'm going to go below. My next x value, which is 12, minus the mean, squared, plus my last x value is 15, minus the mean, squared. Close that. So s squared equals 1 over 3. 7 minus 11 is negative 4. Negative 4 squared is 16. 10 minus 11 is negative 1. Negative 1 squared is 1. 12 minus 11 is 1. Squared is 1. And 15 minus 11 is 4. Squared is 16. So s squared equals 1/3. 16 and 16 is 32, plus 2 is 34. So this is 34 thirds. And remember what I said, I don't really care about the variance, I care about the standard deviation. So I've got to take the square root of this. So I'm going to get my calculator. And I'm going to do the square root of 34 thirds. 3.3665. Okay, so the mean is 11. So that 11 is right there in the middle. The spread, which is how far my data is from the mean, is about 3. So I expect if I go up 3 or down 3 from 11, I'm going to get some data. And then I could go up even more 3 and down even more 3, and I'll get more data than that. But it's saying that on average, my data is about 3 units away from the mean. And like I said, in the next unit and in the last unit, we will talk way more about standard deviation and how it applies to the normal distribution. It has very specific properties that are going to help us define probability. But before I leave here, I'm just going to check myself really quickly. I'm going to go to Stat. I'm just going to enter this data into a list in my calculator. It looks like I have list 3 empty. So 7, 7, 7. 10, 12, 15. Alright, I'm going to go, I like to go to my blank screen. I'm going to go over to Stat, I'm going to go over to Calc, and I'm going to do this one variable statistics, which is where I was finding the mean before. And I'm just going to put in L3. This finds a lot of stuff for me. So one variable statistics of my data, I'm going to calculate, and what I can see here is I get the mean, it's 11. I can see the sum of all the x values. Oh, no, 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 no. Well, you see it on your calculator. So let's see if I can get it up really quickly. And then you should see some place on there that says SX. And I bet if you look at SX, it is the same as the value that we found for the standard deviation. At least I hope it is. So, calc was 3. Sorry about that. No, that's more that you have to watch. Okay, so, oh, there's my standard deviation, S of x, 3.3665, which is what we got. I see the sample size of 4 right there. I also see if I scroll down my 5-number summaries there if I wanted to see it. So I'm feeling pretty good about the answer that I put down.